Hello, bachcho. Beta, we have done 4.3 in partial differential equation, where we have done the reduction of the canonical form of a second order PDE. Basically, how to reduce the second order PDE into the canonical form. That is, you have to transform x and y variables in terms of xi and eta and get the solution of the function u. Now what we are going to do in section 4.4 is to find a general solution. How to find the general solution of the second order PDE? We have learned in the previous video that if the variables capital R, capital S and capital T are constants, 3, 4, 2, 5, just like that, we know how to solve the partial differential equation by finding out s square minus 4rt, whether it is greater than 0, equals to 0 or less than 0. According to that, we find the region, what kind of region it is, and on the basis of that, find the characteristic equation and the solution, right? Then we put the values of psi and eta according to it, and then we find whatever uxx, uxy, uyy is given in your PDE equation, which we are converting into the canonical form, right? And then we put those values in the given equation, and hence we find the solution, the canonical form basically. Now what it is asking is to find the general solution using that canonical form. That means you again will put that xi and eta in the form of x and y. Let's try this example 4.4.1, where it says you have to find the general solution of x square uxx plus 2xy uxy plus y square uyy equals to 0. Alright. Similar method you will follow. What it says, what is R, what is S, what is T? R is x square, cuxx. Along with this, the coefficient is R. S is with uxy, just 2xy, and capital T is y square. S square minus 4rt, what it will be? Find it out. 4x square y square minus 4x square y square. When this is equals to 0, the region becomes parabolic, right? Okay. So the characteristic equation will be, make the characteristic equation. The characteristic equation is, you know that, right? R lambda square plus S lambda plus T. What is R? X square. Lambda square plus S lambda plus y square. No problem, we are going to find the solution in terms of x and y. Find the value of lambda. Minus b plus minus under root b square minus 4ac will become 0 upon 2a, which is x square. Find this, cancel out the common part here. What you will get? Minus pi upon x. Right? Being parabolic, the roots are equal. So 1 lambda we've got. So whatever the differential equation you'll make and find the solution of it, that will be your xi, right? So for the characteristic, we have dy by dx plus lambda, which is minus pi upon x. Find the solution of it. Separate the variables. What it will become? Can I write it like this? We have solved it so many times, this kind of equation. So we have got your xi as y upon x and eta is x and y. You can take anything. We have done it in the previous video, right? So let's take now as y. What will be the answer? First, you have to check the Jacobian. Jacobian of the xi and eta will be what? Del xi by del x, del xi by del y, del eta by del x, del eta by del y. That Jacobian, check the Jacobian whether it is coming 0 or not. Del xi by del x will be, y will be constant. With y upon x, you're differentiating with respect to x. So it will become minus y upon x square. Xi upon y. Y upon x, del eta by del x will be 0. Del eta by del y will be 1. So if you find a determinant here, it will be non-zero basically. This is what I am trying to say, that whatever xi and eta you're going to choose, the Jacobian of it must be non-zero, right? Alright. So we have chosen it. Now, the same procedure. Find out uxx, uxy, and uyy. We know that u is a function of xi and eta, and xi and eta are the functions of x and y. Let's find ux. Ux is what? Del u by del xi? Xi x. What is xi x here? Minus y upon x square plus u eta. Del eta by del x is 0. Right? Y है value. So eta x to 0. So ux is what? U xi of minus y upon x square. Now find uxx. When I am differentiating this u xi, I know that u xi is again a function of xi as well as eta. So what I'll write? It will become u xi into xi x plus u xi eta into eta x, because u xi is also a function of psi and eta, where psi and eta are again the functions of x and y, right? So when you are differentiating with respect to x, it will go this way as well as this way, right? I have differentiated this u xi first with respect to x. This is what I'm getting. And outside this minus y upon x square as it is, plus what will happen? Now I'll differentiate this with respect to x. I'll keep this u xi as such. U xi, we're differentiating with respect to x, right? So minus y will remain as such. X power root minus 2. Minus 2 will come here upon x cube. So what you will write? uxx equals to u xi x is minus y upon x square, right? This will become 0 because eta x is 0. So I'll just remove it here. And I'll write the product minus y upon x square. This one over here. Right? Plus minus plus 2y upon x cube u xi. Alright? Yep. Now you have to find what? uxy. Then uyy. Ux we already know. Now find out uxy. Because ux is u xi of minus y upon x square. uxy, we are differentiating with respect to y now. u xi, I know the function of xi and eta. So if I differentiate with respect to xi, I have to differentiate xi as well with respect to y. Now if I differentiate this u xi with respect to eta, I have to differentiate this eta with respect to y. Minus y upon x square as it is. Now according to product rule, I keep u xi as it is. Minus y upon x square with differentiation with respect to y will become minus 1 upon x square. Correct? So check what you're getting for ux, y. Xi y is what? 1 upon x. Here, xi y is 1 upon x, correct? U xi 1 upon x plus u xi eta. Eta y is 1 minus y upon x square minus 1 upon x square of u xi. So you're getting minus y upon x cube u xi when I open the bracket. Ux y is minus y upon x cube of u xi minus y upon x square of u xi eta minus 1 upon x square of u xi. Right, this is b. Now I have to find u by y. Find u by y. First u y. I know u xi into xi y plus u eta into eta y. Xi y is 1 upon x. Because it was y upon x or minus y upon x. Y upon x. Right? Then u eta into eta y. U eta as it is, eta y is 1. Right? Now I have to differentiate it with respect to y again. So let's differentiate this u xi first. 1 upon x outside. U xi will be u xi xi of xi y plus u xi eta of eta y. Right? 1 upon x as it is outside plus u xi as it is. Differentiation of 1 upon x with respect to y, it will become 0. Right? Thus u eta. Now I have to differentiate this u eta with respect to y. I know eta is again the function of this u eta is again the function of xi and eta. Xi and eta again the function of x and y. So I have to differentiate this u eta with respect to xi. So I'll get this into xi y. And if I differentiate it again with respect to eta, I'll get eta y. Solving this, put the values xi y and eta y. U xi xi y is 1 upon x, right? 1 upon x into 1 upon x. It will become 1 upon x square. I'm writing it very directly. You solve it, but you can every step so that you will not miss out any term. Eta y is again 1. 1 upon x outside is there. So just multiply with it. This plus u xi eta, u eta xi both are same. So u xi eta xi y is again 1 upon x plus u eta eta and eta y is 1, right? So u y is 1 upon x square, u xi xi plus 1 upon x plus 1 upon x will become 2 upon x of u xi eta plus u eta eta. The u xi eta and u eta xi both are the same. I've got this value. Okay, now just substitute in the equation. Equation is x square uxx plus 2xy uxy plus y square uyy equals to 0. X square of uxx. Solve it by yourself. Square you have to multiply with uxx. Here. X square you multiply it, left out with y square upon x whole time. So it will become y square upon x square. Use as y square upon x square u xi plus, I'm multiplying this x square here. X square multiplied, it will become 2y upon x. 2y upon x of uy. 2xy of uxy. uxy, right? X. You find it out by yourself. I'm just writing it over here directly. xy. I think this is what you're getting when you multiply it with 2xy. Right. Plus y square uyy. Y square upon x square. Right. Y square uyy. Y square of 2y square upon x. So y square upon x square of u z I. Y square upon x of u z eta. Plus y square of u eta. Now see if any term is getting cancelled or not. The u z I here, here, and here. Check the positions here. They are getting cancelled. 2y square upon x square is coming. Okay, next. Use I. 2y upon x minus 2y upon x. Use eta. 2y square upon x. Okay, here it is coming 8. Let's check. Use eta. Have I done something wrong here? Use eta was minus 1 upon x square. Okay, I have multiplied with 2y. Let's come 2y upon x. This is right. Y square u eta equals to 0 is left, right? So you're left with y square u eta equals to 0, right? That means y cannot be 0, right? So u eta equals to 0. This is the canonical form that we have reached over here, right? Now the question is asking to find a general solution. So what you are going to do is you are going to solve for the value of u and in terms of x and y at that. So here this is the double differentiation of u with respect to eta. What you're going to do is you're going to integrate it with respect to eta. Integrate with respect to eta. I know it is like an antiderivative. So what I'm left with here is u eta. And I know if I'm integrating with respect to eta, the function is constant with psi. So whatever constant we write in this is an indefinite integral, and in this we find an arbitrary constant, right? Constant of integration. So here that constant will be in terms of psi because I'm integrating with respect to eta, and that psi will be considered as constant. So just write as some constant as f of psi. Now again I have to integrate with respect to eta to find the value of u, right? Integrate Right. Integrate with respect to eta. You'll get what? U in terms of xi and eta, where f of xi is what? Basically constant. That f of xi you are integrating with respect to eta, right? This f of xi will come outside. You have to different integrate, sorry, with respect to eta. So it will become eta times f of xi plus some another constant, which is again the function of xi, right? So this is the basic solution we have got. And what we are going to do is we are going to put the values of xi and eta, whatever we have, plus it out. U of x, y will be eta. Eta was y. F of xi. Xi was y upon x plus g of x. This is the solution that we're getting. The general solution. This is how we are going to do the solutions for the variables given to us. Alright. Let's try some of the examples. Example 4.3.2, sorry, 4.4. Example 2. You're going to try it. It has same constant coefficients, so it is not different than 4.3. We're not discussing it over here. Okay, let's try example number 3 is also the same. Example number 4. Try that. Okay. See the first part of example number 4. What does it say? Find general solution. See, whenever the question is asking to find the general solution, right? So what you have to do is you always have to find xi and eta finally in terms of x and y. In this example, you will also again substitute the values of xi and eta. The question is not asking to reduce it into the canonical form. If the question is saying that you have to find the general solution, that means you have to convert the values of xi and eta. That means whatever the canonical form you are getting in terms of x and y. Alright, let's see the fourth example. Let's try the first and the third PDE. Second part you will try. You have to find the general solution of the following equation. The first equation is y uxx plus 3y uxy plus 3ux equals to 0. The same steps again. What is r here? What is s? What is t? T is what? 3? No, 0. Because uy's coefficient is what? 0. Right? Now find s square minus 4rt. Y square is always positive. 9y square will always be positive. And positive region hyperbolic. Let's find the characteristic equation. So the characteristic equation will be r lambda square plus s lambda plus t which is 0. Just the same steps there. Solve it for lambda. So either lambda will be 0. Distant proofs are here. So for this characteristic, the differential equation becomes I have reached to these two equations of this differential equation. So the next step is, right, innovate further, check the Jacobian. That means differentiate xi with respect to x, xi with respect to y, eta with respect to x, and eta with respect to y. So what we are going to, this is 0, 1, minus 3, 1, 1, 0. Okay. Now, given equation was uxx, uxy, and ux. Do it. Same steps will be followed. And equals to y, eta equals to y minus 3. Ux will be x will become 0. Eta x is minus 3. So ux will be minus 3 u eta. Now differentiate it again with respect to x. Minus 3 is constant. U eta, you will differentiate with respect to xi with respect to eta. Correct? Xi x is 0. So u eta x is minus 3. So ux is 9 u eta. Now find uxy. Now uxy. Now uxy. Ux is minus 3 u eta. So I have to differentiate this u eta with respect to xi and xi with respect to y. And u eta with respect to y. Right? So what is uxy? Xi is 1. So minus 3 u eta y. Eta y is what? 1. Minus 3 u eta. Right? Now find uy. What is uy? Uy is u xi into xi y. Xi y is u eta y is again y. Now substitute these three values in the given equation. Given equation is what? Y uxx plus 3y uxy plus 3ux equals to 0. The y is not equals to 0, right? So 9y u eta plus 3y of uxy. That is minus 3 u eta y minus 3 u eta plus 3 times uxi plus u eta. Right? And solve it further. See the terms here. 9y u eta and this minus 9y u eta. So it will become minus 9y of u xi eta plus 3 u plus 3 u eta. Right? This is what we are getting. Eta y. No, y is 1. Minus, this is 9y u eta minus 9y u eta minus 9 u eta plus 3 Maybe missed something here. UX. I think UX was there. Okay, I have written UI. UX is there. So there's no need for this. We just simply need UX, right? So what is UX? A3U eta only. Means U eta. It is y times U psi eta and plus U eta equals to 0. Right? And what this U is in terms of psi and eta, and this U is also in terms of eta. I can replace this y in terms of psi and eta. Y is equals to psi. So what will be my value of U in terms of psi and eta? Psi times U psi eta plus U eta equals to 0. Now how will you solve it further? Think. What we are going to do is, let's just put this U eta as some V. This is the important part. Put U eta as some V. What will become? Psi times U psi eta was there, right? And this U eta is V. So what will this become? U psi eta is same as U eta psi. So U eta is V and U eta is V. So U eta psi will be V psi, right? So the equation will be what? Psi times of V psi plus U eta, which is V equals to 0. Now I've converted this basically in the first order PDE to solve this. Check what you're getting. Psi times of V psi, यानी कि psi times of dV upon dz, right? That means psi times of dV upon dz plus V equals to 0. Solve it. dV upon V is equals to minus dz upon psi. Log V equals to minus log psi plus log C. So can I say log V plus log psi equals to log C? So what will be the value here? And this constant, what will this constant looks like? Just like the previous example we have done, this log C I can write as a function of eta. Here also this log C I can replace again as function of eta. So what will be the value? V psi is equals to f of eta. V psi as function of eta. It will become e to power, or just write f eta as log of f of eta. It won't matter, right? Then log will get cancelled out. Basically, in the right hand side, you will get a function of eta only. What is V here? U eta, just replace it. Right? Now I have to integrate this U with respect to eta to find U, correct? So what I'll do is just keep U eta over here and take the other terms to this side. Integrate with respect to eta, it will become U in terms of psi and eta. We are integrating with respect to eta, so psi will be constant, 1 upon psi will come out. F of eta, you are integrating. So I have to integrate whatever f of eta is with respect to eta, plus some constant, and constant is the function of psi, right? So what I can write here, I don't know function of eta, So I don't know how to integrate it. What will be the value? So I keep this whole function as some eta value. So I can write this u in terms of xi and eta as 1 upon xi of g. I have done already. Let's take h of eta plus g of xi. Now I know the values of xi and eta, and I'll get the general solution. What is u? Sorry, what is xi? Is y. Eta was, I guess it was 1 minus 3x. Y minus 3x. X and y in terms. 1 upon y is y. Y is 1, so it will become 1 upon y. H of y minus 3x plus g of y minus 3x. Done. Alright. Similarly, try the second part of this. We are going to do the third part. The part says uxx plus 2x uxy plus 5uyy plus ux equals to 0. Here all the three terms are there. uxx, uxy, uyy. So rs and t are there. Find out whether the region is parabolic, elliptic, or hyperbolic. Less than 0 is coming. So the region is what? Elliptic. Find out the characteristic equation. So what it will become? Find the characteristic equation. Lambda square plus 2 lambda plus 5. Find out the solution. Minus b plus minus root b square minus 4ac upon 2a. I'm not finding here. I'm just telling you that this is the answer that you will get when you find the value of lambda. So here it is minus 1 plus minus 2 iota. So there again, two equations will be found. So what will be the partial differential equation, the differential equation found? We take the differential equation divided by dx plus minus 1 plus 2 iota and divided by dx plus minus 1 minus 2 iota. We've done it already in the previous video, right? We know how to solve these differential equations. So I'm writing it here directly. 2 iota of x and we know what we are going to take as xi and eta. Xi and eta will be sum of the values here, these values plus these values upon 2 and difference of these upon minus 2 iota, right? Do it. Let's take consider p as y plus minus 1 plus 2 iota of x and q as y plus minus 1 minus 2 iota. Put xi as p plus q by 2 and eta as p minus q by 2 out. Do it. P plus q. 5 plus y will become 2y. Minus 1 will become minus 2x. Right? Iota term will get cancelled. Xi we have got as 5x. And for eta, y minus y minus 1 plus 1. 2 iota plus 2 iota. 4 iota x upon 2 iota will become x. Rest you know how to solve. We are solving it till now already. U of x will be what? U xi into xi x, which is minus 1 plus u eta into eta x, which is 2. Uxx minus outside u xi with respect to x xi x will be minus 1 plus u xi eta. Eta x will be 2 plus 2 times u eta. U eta xi x is minus 1 plus u eta eta into 2. Right? I hope till here it is clear. If not, ask me anytime. Alright? U xi. I'm opening the bracket only. U eta xi I can write as u xi eta. So I'm writing it over here. Right? So with the value we're getting uxx as u xi minus 4 u xi eta plus 2 u eta eta. Your equation is consist of uxx, uxy, and uyy. Let's find uxy. Uxy. If I look over here, minus of u xi of xy plus u xi eta of eta y plus 2 times u eta xi of xy plus u eta eta of eta minus of u xi of xy is what? 1. Eta by 0. So this term will be cancelled. So minus of u xi plus 2 of u xi eta. Eta y is 0, so another term will be cancelled. Right? Let's see. Now find uxy. Sorry, uxy we have done, uyy. What is uy? Uxy into xy, right? And xy is 1. So uxy plus u eta into eta y. Eta y is 0. Right? So uy is uxy only. Now check for uyy. Uxy into xy. Xy is again what? 1 plus uxy eta of eta y. Eta y is what? 0. Now substitute these values in equation. It was uxx. Uxx is u xi minus 4 u xi eta plus 2 u eta eta. Right? Plus 2 times uxy. What is uxy? Minus u xi plus 2 u xi eta. Here plus 5 times u xi plus ux. What is ux? Minus u xi plus 2 u eta. Minus u xi plus 2 u eta. Check what term is getting cancelled. U xi minus 2 u xi 3. Four u xi. This is getting cancelled. Coming 4 u xi plus 2 u eta eta minus u xi plus 2 u eta. This is the solution, right? In this case, we are unable to find the general solution because it is becoming complicated. If we integrate it with respect to eta, what will happen? We don't know how to integrate this u xi with respect to eta, right? So we're not moving it further. We just say that this is the solution. Alright, is the solution, as it's not easy to find it in these equations. Alright. Now you're going to try question number 12. Right, question number 3. I've done already question number 12 of this exercise by yourself. Alright. The last example of this section is left, which I'm just discussing over here. You will try it on your own. Alright. Example number 5. What it says is u is a function of xi and xi is function of x and t, x by root 4 k t. K is a constant. Right? To solve the parabolic system is ut is equals to k uxx, where x is belonging to minus infinity to infinity and t is positive. Right? Also, what is given? That u at 0 value of t is 0 when x is less than 0. And when x is greater than 0, this ux of 0 is u0. Right? Solve it. What are you getting? Also, there's one rule review here, that the integration of e to the power minus x square dx from 0 to infinity value is root pi. And if you have negative 0 to minus infinity, if I'm saying, then the value is minus root pi. Alright. This in particular we are going to use. You have to keep these integrations in mind. Alright. Now solve it. X you need, ut is required to substitute the value in this given equation. And u is a function of xi, right? Let's find ux first. And xi is function of x and t. Xi is a function of x and t. Right? And u is a function of xi and theta. Right? Sorry, u is a function of xi only over here. It is given to you, u is f of xi. Sorry, my bad. Alright, so ux is what? Because u is a function of f of psi. So ux is what? You'll differentiate this f of psi with respect to x, right? So this differentiation into xi x. And what is xi? X upon root 4 kt. You have to differentiate it with respect to x. So it will become what? 1 upon root 4 kt. Right? Now uxx. Now I know that this xi is function of x and t both. So what I'll do, if I differentiate this, if dash of xi is again a function of x and t. If I'm differentiating it with respect to x here, what it will become? F double dash of xi into 1 upon root 4 kt as it is, plus f dash of psi into differentiation of this, which is 0. So they have not written xi x over here, no? Xi x is 1 upon root 4 kt. So what is uxx you're getting? F double dash of psi, can I write it as u xi upon 4 kt? Right? Now here the next was ut. ut is what? Again, differentiate this f of xi, the used function of f of xi, and differentiate with respect to xi and xi with respect to t, where xi is what? X upon root 4 kt. So ut will become what? U xi of xi t is what? X. This root 4 kt, when you solve, what it will become? First, you have to solve this root. So it will become what? Minus 2 4 kt power 1 upon 2 plus 1. It will become 4 kt power 3 upon 2, right? Into 4k. That. Now substitute these values in the given equation. Given equation is ut is equals to k times uxx, right? Solve it. Whatever value you're getting, just integrate because you have got this u xi and u xi. U xi and u xi you have got. What you're going to do is just find by substituting the values of ut and uxx here. Just solve the double differential equation you're getting by integrating it with respect to psi. Because I'm seeing over u xi's are coming over here, right? So differentiate and just put the value of xi and eta in the given equation. You will get your value of u in terms of x and t. Correct? Just do it. If you come up with any problems, just ask. Alright. I'll tell you the questions which you have to do. Question number 5, 6, and 8 we will try. They are based on these kind of equations. Alright. Next we'll discuss. Otherwise, we'll start chapter 7 first. Then we'll start chapter 5. Okay.